Hey guys, it's Figueroa here. I just wanted to make a quick, it might not be even quick. I don't know how long I'm going to take on this video, but I wanted to make a video for Chapter 17 quiz review. So I just kind of wanted to talk about the difference between when to use just the basic normal model versus if you have to use the sampling distributions for sample proportions versus sample means. So I will probably post this document on Google Classroom so you guys can take a look at it if you don't want to spend time actually jotting these things down. But what I really wanted to talk about was just the difference between these. So the normal model, in the context, it will not state a sample size. It'll specifically say that the distribution for the specific context is a normal model. So you will not see a sample size. So if a sample size is mentioned, then you have a sampling distribution and you must check your conditions for using a normal model. And then you guys on the quiz tomorrow will have to be able to calculate the z. So you have to figure out if it's a z for the normal model, or if it's a z for the proportions, or whether or not you have to use the z for the means, okay? So for the normal model, we have z equals x minus mu over sigma. And then for the sampling distributions for sample proportions, the context is going to state a percentage. So you might see on the specific example, it'll say 54% of Americans, because that's giving you a percentage. So that's telling you that this is going to be a sample proportions example. And then those three conditions for sample proportions we have are the first two are the same as the sample means. But we have to have a random sample or a representative sample. So sometimes it might talk about being in a class of 30 students. Those students aren't necessarily randomly placed into that classroom, but those 30 students would be representative of the school. The second condition has to be reasonable that it's independent. Like, for example, flipping a coin doesn't necessarily have a population, so you wouldn't say that flipping a coin is less than 10% of the population, because that doesn't make any sense. So it needs to be reasonable that the sample is independent, or the sample must be less than 10% of the population. And then the third condition is that the successes and failures need to be at least 10. So n times p and n times q both have to be greater than or equal to 10. So a way to remember your three conditions, I would say, is condition number 1 has to be random sample. Condition number 2, it has to be small enough. Oops, I can't spell. Small enough. Condition number 3, your sample has to be big enough. So the small enough, just remember less than 10% of the population, and condition number 3, your sample has to be big enough, greater than or equal to 10. And then if the three conditions are satisfied for the sample proportions, then we can use a normal model with mu of p hat is equal to p, and then sigma of p hat is equal to the square root of pq over n. And you guys need to know how to calculate these on the quiz tomorrow. It'll give you it'll say what is the mean and standard deviation for the sample proportion or whatever. And then it might ask you different words. It might say the mean and the variance, the center and the variance. So you just need to know center is talking about the mean and variance is asking you about the standard deviation, okay? And then here's the z-score for sample proportions. You don't have to memorize this. This is on your formula sheet, but not exactly. On the formula sheet, it states it as standardized test statistic, which is the statistic minus the parameter over the standard deviation of the statistic. But kind of what I told my students was the p hats and the x bars, this is for the sample. And then the p's and the mu's, that's for the population. Oops, I can't spell again. So the sample, it's always the sample minus the population over the standard deviation for the sampling distribution, okay? So in the quiz tomorrow, you will have to be able to calculate the z-scores. So you need to make sure you know the how to do that. And then the sampling distribution for sample means, the context is going to state the mean and standard deviation. So it'll give you the average family size is 2.5 and a standard deviation of 1 or something like that. Okay? So in the context, it'll give you the mean and the standard deviation with a sample. And then again, your conditions is, the number 1 is random. Number 2 is it small enough. Oh my gosh, I can't spell today. Is it small enough? And then condition number 3, is it big enough? So the difference between sample proportions and sample means, proportions is the successes and failures have to be at least 10. And then for means, your population is roughly symmetric and unimodal. So that's if you know that the population is like normal, then you can use the normal model. But if you don't know that your whole population is normal, then you have to check to see if your population is large enough that the central limit theorem gives us an approximately normal distribution. So if your sample size is greater than or equal to 30, then we can say that it's going to be the normal model, because the central limit theorem tells you that as your sample size gets bigger, your distribution starts to begin more like, starts to begin to look more like the normal model. Excuse me. And then by the central limit theorem, we can use a normal model with, again, you guys need to memorize these things, so let me find my different colored pen. This right here, mu of x bar is equal to mu, and sigma of x bar is equal to sigma over the square root of n. And again, make sure you guys need to make sure you guys know how to calculate those for the quiz tomorrow. And then your z-score again is over here. Remember, x bar is for the sample, and then mu is the population mean. And then this right here is your sampling standard deviation. And then this sigma right here is for the population standard deviation divided by the square root of the sample size. Okay? So that's kind of a recap of what the difference is. And again, I'll post this on Google Classroom maybe later. I'm not sure if it'll have my notes on there for you guys, but I'll post this on Google Classroom. All right. Then I kind of wanted to just go over some examples and what to do in the difference, okay? So if you look at your exercises 17.1 in the first page, I wanted to go over like number 2. So if we look at number 2, it says, based on past experience, a bank believes that 7% of people who receive loans will not make payments on time. And the bank has recently approved 200 loans. So this right here tells me this is a sample. So I know I'm going to have to do a sampling distributions. And then because this is a percentage, this is now telling me that this is a proportions example. Okay? And because I have a sample, I'm going to have to do a sampling distribution, which is why you can tell in part B is asking you for the conditions. Are the conditions met? Anytime you have a sampling distribution, you should check your conditions, okay? So if I look at this one, it says your first example is the, your first condition has to be random sample. So the 200 loans were randomly selected. I'm not going to write that down because it'll take me a while. And then condition number 2 is it small enough? So 200 loans is definitely less than 10% of all the loans. And then your third condition is your success failure. So I'll actually go over that one. So your N in this example ends up being 200. My P is the population. 7% of people don't make payments on time, so that's going to be a 0.07, and then my Q is going to be 1 minus that, so my Q is going to be 0.93. So if I check my third condition, again, I'm just not writing 1 and 2, but you should write 1 and 2. And then my third condition, I'm going to check n times p, which is 200 times 0.07, and that should give you about 14, I believe, and that's going to be greater than or equal to 10. And then your NQ, that's going to be 200 times 0.93, which ends up being like 186, which is greater than or equal to 10. So yes, the conditions were met. So now that I know that, I am asked to find like the mean and standard deviations of the proportion of clients in this group who may not make timely payments, okay? So if I go back to my notes for mean and standard deviation for proportions, sampling proportions, I have these right here. Mu of p hat is equal to p, and your sigma of p hat is equal to the square root of pq over n. So I have my mu of p hat is going to equal to p, and my sigma of p hat is equal to the square root of pq over n. So I know that my mu is going to be the same as p, so my p is 0.07. So my mu is 0.07, and my sigma, you have to actually calculate that. That's going to be the square root of p times q, so 0.07 times 0.93 over n, which is 200, and that ends up giving you approximately 0.018. Okay, so that's calculating mu and sigma. You for sure need to know how to do this for the quiz tomorrow. And then for part C, it's going to ask you what is the probability that over 10%. Anytime it asks for probability, you want to calculate your z-score, okay? Even though your calculator can tell you a straight answer without finding z, remember on the AP exam, the AP readers want to see that you understand the statistics. So in order to do that, it's best to calculate a z-score, okay? So this is asking for the probability that it's over 10%. So the 10% is going to be like right here. And it's asking for over, so you're shading above, okay? So in order to do that, you want to calculate, again, this is the proportion, so if I look back to my proportions, here's my formula for proportions. I have p hat minus p over the square root of pq over n. So I have my z is going to equal the p hat, which I haven't calculated. You don't have to because it's asking for over 10%, so that is going to be your p hat. Okay, so p hat is going to be a 0.10 minus p, which is 0.07, over your standard deviation, which I already calculated over here, so I'm just going to go 0.018. And if you calculate that, you end up getting 1.67. And then you just use normal CDF on your calculator to find the probability for z being greater than or equal to 1.67. And that's just normal CDF on your calculator. You should get 0.047. Okay? So for sure, make sure you know how to do like 2A and 2C for the quiz tomorrow. You need to be able to know how to calculate z, and you need to know how to calculate probability. You need to be able to calculate mu and sigma. Alright, another one that I wanted to go over was, let me look at my notes here, was 17.3, I believe. So if you look at your exercises 17.3, this one with the histograms, I wanted to go over part B. So this is 17.3, number 2, and this is on page 3 of your exercises. So this one says to explore how the mean might vary from the sample to sample. They simulated by drawing many samples of size 2, 5, 10, and 20 with a replacement from the 250 measurements. So here are the histograms of all the sample means. And then your job was to explain how these histograms demonstrate what the central limit theorem says about the sampling distribution for sample mean. So if I look at each of the histograms, this is a size 2. So my size 2 This kind of to me looks slightly skewed. I can see that it's a little bit, the tail is kind of more towards the right side. So that's slightly skewed. And then as my sample size gets bigger, it's not so skewed anymore. It starts to look a little bit more normal. But the edges are kind of like off. See, like that one is not necessarily symmetric. That one's not. And then my next one's not. So they're not necessarily symmetric yet, but it looks pretty symmetric. And then if I look at my size 10, it starts to look a lot more symmetric. Like this is pretty much aligned to that one. This one not so much, but it's better than the previous one. Like they start to get closer to each other. So it becomes more symmetric and more normal. And if I look at the size 20, my size 20 definitely starts to look a lot more normal. You can see from like size 2, I have a whole bunch of bars for my histogram, and my size 20, they start to decrease. That's because they're getting more bunched up together. So it starts to look more like the normal model. So the central limit theorem pretty much tells you that as your sample size gets bigger, so as sample size increases, we begin to see the sampling distribution of means becomes more symmetric. And normal in shape. Okay, so that's pretty much what the central limit theorem says, that as your n starts to get bigger, your distribution starts to begin to look more like the normal model. All right, the last thing I wanted to go over was an example on 17.4. So if you go to 17.4, page number 5, I wanted you guys to go over number 1. Okay, so if you look at 17.4 in your exercises number 1, the context here says, assume the duration of human pregnancies can be described by a normal model. So this, the population is normal, and it gives you a mean and a standard deviation. And it's asking for, like, what percentage of, oh, well, let me stop there. Does this question anywhere say so far in number 1 whether we have a sample size or not? I don't see a sample size, which tells me this is not a sampling distribution just yet. So if we look at part A, what percent of pregnancies should last between 270 and 280? This is just a regular z. So this, you're just going to do z equals x minus mu over sigma for that. Okay. Part B, still not sample size, but then if you look at part C says, suppose a certain obstetrician is currently providing prenatal care to 60 pregnant women. So this is now a sample. And because I have a sample, this now tells me this is a sampling distribution. So then you would have to have calculated your check your 3 conditions. Excuse me. So your first condition is the random samples. So 60 pregnant women, they weren't, like, the doctor didn't randomly select those 60 pregnant women, but we can say that those 60 pregnant women would be a representative sample of all pregnant women. Then our second condition is, do we have a small enough sample? So 60 pregnant women is definitely less than 10% of all pregnant women. And then our sample size needs to be big enough. This is a means problem, so n is greater than 30, 60 is greater than 30. So then we can say the central limit theorem tells us that we can use the normal model. So we have to specify the model. We're going to say use the normal model. I kind of just said the conditions, but you definitely want to write them down. So we can use the normal model, and it says calculate the mean and standard deviation. So with a mean, So mu of x bar equals mu, which is up here 266. And standard deviation would be standard deviation over square root of the sample size. So it would be 16, over the square root of 60. Let me calculate that really quick. And you should get 2.066 days, because we were talking about the pregnancy, how long the pregnancy lasted. Okay. And then if you look at part D, it's asking what's the probability. Again, anytime you ask for probability, you want to calculate z. So my z for means is x bar minus mu over sigma divided by the square root of n. Okay. So what's the probability that the mean for these patients, talking about part C, will be less than 260 days. So this 260 is going to be my sample, or sorry, not my sample, but it's going to be x bar. So I have 260 minus my average is 266 over this. I have it right here, so I'm just going to put 2.066. So my z is going to be approximately negative 2.9. So then you are going to find the probability that z is less than or equal to negative 2.9, and that ends up being approximately 0.00187. So this is about 0.187%. It's very rare for this to happen, okay? But again, on the quiz, you definitely want to be able to do this, calculate sigma and mu. You want to be able to calculate z, and you want to be able to calculate the probability. So make sure you know how to do that for tomorrow's quiz. And sorry it took so long on this video. I didn't expect to last 22 minutes, but good luck on your quiz tomorrow.